Okay, now this is our second part of the lesson. We are now going to look at this question. Okay, please look at this question. Two experiments are carried out to investigate the factors affecting the rate of reaction. Okay, now see here. Assessing react with 25 centimeter cube, 1 mole per decimeter cube of the hydrochloric acid at the temperature of 30 degrees Celsius and 40 degrees Celsius. And the volume of gas collected at 60 seconds is given to you to be 20 centimeter cube and 32 centimeter cube. Okay, now from the reactants here, what are the same? Shall we hear from our friend Kaizi? What are the same?
The volume and the concentration.
Good. The volume and the concentration of who?
Of the hydrochloric acid.
Yes, the volume and the concentration of the hydrochloric acid should be written in a specific way. So this is the constant variable. Okay. Now zinc is in SS. What is the MV here for these two sets of experiment? Can someone tell me? Shall we hear from Joseph? What's the MV here? Sorry?
MV for what here?
MV for these two sets of experiment.
0.025. 0.025.
MV means the manipulated variable.
Oh.
MV means the manipulated variable.
Temperature.
Okay. Yes, is the temperature here. One is at 30, another one at 40. Therefore, the temperature is the one to affect the rate of reaction. Okay. Now, for your information, there are 5 factors which affect the rate of reaction. Okay. Now, factor number 1, it will be what we are learning today, the temperature. Okay. Now, factor number 2, it will be the concentration. Factor number 3, it will be the this one will be the size of substance. Okay, meaning we are changing the size of the zinc. We may use the zinc strip, we may use the zinc powder. Number 4, the presence of catalyst. And number 5, we are going to talk about the pressure. So today we are going to talk about the temperature first. And I don't follow the sequence of your textbook. You follow what I am doing so that you know what is really happening. Okay, now see here. The temperature is the factor that affects the rate of reaction. So therefore, part A, what is the factor that affects the rate of reaction in both experiments? Your answer is temperature. With this, easily, you get 1 mark. Okay, now continue for the next part of the question. Write the chemical equation for the reaction outcome. I think you should have no problem in writing this chemical equation. Okay, where you should be getting Zn, zinc, zinc should be Zn, no 2 positive, reacts with hydrochloric acid, HCl, you are getting zinc chloride. The zinc ion, which is Zn, 2 positive, the chloride ion, Cl negative. Take the number 2 cross it, take the number 1 cross it. You are getting ZnCl2. And from your chapter previously, when acid react with reactive metal, you are going to get salt and hydrogen gas produced. Now balance up the equation, you put a 2 here. Okay, this is the chemical equation. Now next part, calculate the average rate of reaction for experiments in set 1 and set 2. This is revision from what we have done just now. So everyone, please calculate. If you have problem to get the answer, can you see here, this part? Volume of gas collected at 60 seconds. That means the time is 60 seconds, the volume is this. Now, when you are calculating, let's say this question is changed to become an essay question. When you want to calculate, you please write like this. You are calculating for set 1, right? So you write set 1. Then the average rate of reaction equals to, it will be the volume divided by the time taken. So what will be the volume? This is the volume, 20 unit centimeter cube. Time taken, can you see? 60 seconds. Okay, therefore you are getting how much? Is it 0.33 centimeter cube per second? I hope you get this. Okay, now we are moving on for set 2. So you write again one more time, set 2. Okay, the rate of reaction, again, volume versus volume divided by time. This time the volume now is 32.0. Okay, time taken 60 seconds. Someone press your calculator, please.
0.53.
0.553. Is it?
53.
53. So I put it as 0.53 centimeter cube per second. Now from here, which set will have a higher rate of reaction? The answer should be set 2. Can you see the value to be bigger? Value to be bigger? Okay. Now from here, we can make a conclusion that okay. Now from here, we can make a conclusion that when the temperature increases, rate of reaction increase. Okay. Now, when we are talking about rate of reaction, you are using the word higher or lower, no using faster. Okay. Now, why when temperature increase, the rate of reaction increase? Now, let's say when you are cooking something, when the temperature increase, let's say you are frying the beans in the pan, you'll find that the pan in the pan, the beans are popping out very fast when the temperature increase, and it actually relates to the kinetic energy. Okay, therefore, when the temperature increase, actually the kinetic energy of particles increase. Okay, now when the kinetic energy of particles increase, it makes the particles to collide with each other easily. Now, why do I talk about collision? Okay, now before I continue, we are going to continue here by writing the chemical equation. Just now I write for you this. Okay, now from here, everyone write for me the ionic equation that represent this reaction. For those who have forgotten, I repeat, when you want to write ionic equation, if it is a solid, a gas, atom, molecule, gas, solid, atom, molecule, you are going to write back. Okay, just copy back. Because the particles, let's say it is zinc atom. The zinc atom, the zinc consists of zinc atom. So it is Zn only. Okay. But then when it is HCl a solution, what will happen is the hydrogen ion and the chloride ion present in the aqueous solution. And you see a 2 in front, so you are going to multiply in the 2 and 2. Now the zinc chloride is a solution. Therefore, you have to separate it into the ions. You are getting the zinc ion and the chloride ion. Okay. Now you see a 2 here. The 2 multiply in, so you get a 2 chloride ion. 2 mole of chloride ion. This H2 is a gas molecule. So you write back. Okay. Now you look for what is the same on the left and right. The zinc and zinc ion, they are different. So just leave it. These two are the same. Bring this to the other side, it becomes minus. So you cancel it off. Therefore, what is left, which is the zinc, reacts with the hydrogen ion to form the zinc ion and the H2. These two are what we call it as the colliding particles. Okay, where this chloride ion is actually what we call it as the spectator ion. Spectator ion. Okay, now continue with the story up here. This is point number 1, point number 2. Now we are talking about point number 3. When the kinetic energy of particles increase, actually, in this case, the frequency of collision between, now we are talking about these two types of ions, these two types of particles, between who? The zinc atom and the hydrogen ion. Zinc atom, remember to put the atom, and the hydrogen ion increase. Okay, now previously I told you, when a reaction occurs and it produces product, the particles must collide with each other. If it does not collide with each other, then the reaction, the product will not be formed. And some more, if it collides with each other, it must follow 2 requirements. Requirement number 1, it should achieve the activation energy. Requirement number 2, it should be at the correct orientation. Okay, those who miss this about the correct orientation and the activation energy, no worry, I will come back to it later. Okay, now when the collision occurs, collision means this zinc atom and the hydrogen ion, they hit each other. When they hit each other and they achieve the 2 requirements just now, which is the activation energy and the correct orientation, meaning the products will be formed. This type of collision, we call it as the effective collision. Therefore, when the collision, the frequency of collision increase, the frequency of, this time we are talking about the effective collision. Okay, between who and who? It will be, it will be between the zinc atom and the hydrogen ion will increase. Okay, so this is related. I hope you can follow this. I repeat, first of all, we are writing about the, I'm using the purple, we are writing about the factor. This is the factor, okay, the temperature. Then we talk about the keywords, the kinetic energy. Okay, then we talk about the frequency of collision. Make sure you write about the particles which collide. How do you determine the particles which collide? We get from the ionic equation. Okay, then we talk about the frequency of effective collision. Again, between the particles which collide. Can follow what I mean until here? I hope you are okay. Therefore, when the temperature increase, the rate of reaction increase. Okay. Now, number 1, 2, 3. This should be the 3, and this should be the 4. These 4 sentences is what we say that we are explaining based on the collision theory. You see from your textbook, you will see this word. Explain based on collision theory. This is the collision theory, where we are talking about the collision between the particles. Okay, now we move on. Go back to our question. This is our question just now. This one, okay, now here. If I were to ask you to sketch a graph to represent these two reactions on the same axis, now what does it mean? Meaning, we are going to sketch a graph. I'm using this partner. Okay. This one. Okay. And here. Now this will be the x-axis and the y-axis. Okay, now we are going to label. This will be the volume of gas. Don't forget about the unit, centimeter cube. This will be the time taken. If we assume that this reaction complete, okay? Don't follow these numbers. We assume that this reaction complete. So now we are going to sketch a graph to represent these two sets of experiment on the same axis. So these are the axes that we are using, the time and the volume of gas. This is the responding variable. We are recording the volume of gas at 30-second intervals, let's say. Okay. Now we continue. Just now we know that when for this set 2 the temperature is higher, sorry, I pressed something accidentally. Okay, we continue on the here. Easier. Okay, here. Now I draw back the axis, which is this number 1, the y-axis, and here the x-axis. Okay, this should be an arrow here. This should be an arrow here. Okay, now you label the axis. This part should be the volume of gas, unit centimeter cube. This should be a superscript, and at this part, this will be the time taken, which is measured in second. Now you have two graphs just now, meaning to say you will have two lines. How will be the two lines be? You will start from the origin, because when it is 0 second, no gas is released. Therefore, your graph will be line number 1, and you have another line. It will be here, number 2. Okay. Now, I want to know whether the volume of gas of these two sets of experiment will be the same or not. The volume of gas released at the end, will they reach the same maximum volume of gas? Should we hear from our friend, Ai Wei?
Yes.
Yes, okay. Everyone agree with Ai Wei? If you agree, show a like, please. Okay, someone agree, someone does not. Just Nick, do you agree? Okay. Some of you agree, some of you not. Vernon, agree, ah? Okay, now we continue. Actually, the volume of gas released, the total volume of gas released, the maximum volume of gas released will be the same. Okay, what's the reason? Why will be the same? Because for these two sets of experiment, they are using the same volume of the volume and concentration of the solution. Okay, and the zinc is in excess, meaning to say the number of mole, yeah, the number of mole of the hydrochloric acid for both sets are the same. When the number of mole for the hydrochloric acid are the same, meaning, again, we can talk about the ratio. Okay, let's say we ratio the HCl to the hydrogen gas. It will be 2:1. And later, when you do your calculation for the number of mole, you'll find that they get the same number as well. Therefore, they will reach at the same height. When it will reach at the same height, meaning to say, it will be this one, like this, okay? For this, it will go up smoothly, and it will reach here. Both of them will connect at the same height here, okay? Of course, when you draw it nice, huh? And which set will have the higher rate of reaction? Just now, we know that the set 2 is having higher rate of reaction. Therefore, this line is higher. This is lower. Okay? Why do I choose this line to be higher, this line to be the lower? Because from our early of the lesson, we know that the gradient of the graph represents the rate of reaction. Okay. Now I repeat, what am I trying to talk about from here is that, number one, from the two sets of experiment, we are sketching a graph on the same axis to show the rate of reaction for both sets of experiment. So I choose the axis to be volume of gas versus the time taken. I have two sets of experiment, so I will have two lines, the green and the red. Now, why is that these two lines will join at last? This is because the number of mole of the hydrochloric acid used for the two sets of experiment are the same, and it indirectly affects that the volume of the hydrogen gas which is released during the experiment is also the same. Therefore, they will reach at the same height. Now, when I want to determine which line is for which set, then we are going to see, oh, for set 2, the temperature is higher, so the rate of reaction will be higher. Therefore, the line with the higher gradient will be the line for set 2, which has higher rate of reaction. The line which has lower gradient, which is the green one, is for set 1, because set 1 has lower rate of reaction. Okay? Are you with me? Are you okay? If you are okay, you please show me a like for this part. Okay, good. Thank you very much. Okay, now we continue to the question. Okay, now we continue to the question here. Just now I say you write the chemical equation, the same question, same question. This is the part that we have already determined the factor. We have written the chemical equation. We have calculated the average rate of reaction. Now see, what is the question going to be asked? Okay, see, sketch the graph of the volume of gas versus against time for set 1 and set 2 on the same axis. The answer is the one that we draw on the whiteboard just now. Now here, compare the rate of reaction between experiment 1 and 2. So which one will have a higher rate of reaction? Shall we hear from our friend? Who wants to tell me your answer? Anyone volunteer? No one. No one.
Set 2.
Huh? Who?
Set 2.
Okay, set 2, good. Now, set 2 is the one which is having higher rate of reaction. And explain your answer using collision theory. Have I given you the answers just now? Yes, the one on the whiteboard also with 4 lines typed for you. Okay, so with that, we have completed one example of SPM question. And this is actually taught in your textbook, from your textbook, in different subtopics. I combine and teach using exam questions. Okay, now the next part of the question, can you see? Another example of the question. Experiment is carried out to investigate the rate of reaction. Again, you see the zinc with the hydrochloric acid. The volume of gas release is given to you. Now, state the meaning of rate of reaction. What is the meaning? I've already told you last week, where it is the change of physical quantity of reactant or product per unit of time. Remember to put per unit of time. Now continue. Writing balanced chemical equation, again repeated, so I don't repeat about it again. Next, from the graph, you are asked to determine the concentration of the hydrochloric acid used. Okay, now this is your homework. This is your graph. Later I'll post this in the group so that you can do this question as your homework. Number 2, we will discuss tomorrow in our lesson. Okay, now the calculation for the concentration you have to do as homework. Next part, average rate of reaction. Can you calculate? No problem, right? Now here, based on the collision theory, explain why does the rate of reaction decrease with time? Okay, here actually they are talking about the change in concentration. Can you see? Can you see? When the graph goes up, meaning more product is formed, the reactant is getting lesser and lesser. So actually they are trying to tell you, as the concentration of reactant decrease, the rate of reaction also decrease. Okay, now we continue. You have to explain based on the collision theory, and you are going to repeat this using the sulfuric acid. Sketch the curve on the question given here. Okay, now question number 2 is your homework, and also the question number 3, your homework as well. 2 and 3, okay, 2 and 3. Any problem? No problem, Okay, before we end our lesson today, I need to give you the factor. I need to give you the factor and also the keywords. Okay, now everyone make a table. Make a table. Okay, this is a table. Now on the left hand side here, this part will be the factor. This will be the keywords. Okay, the first factor that we have discussed just now will be the temperature. And the keywords just now I have mentioned to be the kinetic energy of particles. Okay, now I give you the second keywords. which is the concentration. And the keywords will be number of particles per unit volume. Okay, I give you these two first. Some more we will add in until number 5. Okay, now for your information, the factor on concentration and also the pressure will have the same keywords, which is number of particles per unit volume. These are separate. This is factor number 1 that we have studied. This is factor number 2 and 3. 1 and 2. Okay, so you have to remember these two. Tomorrow we are going to discuss about the concentration. So I hope you can read from your textbook about the concentration before we move on to our lesson tomorrow. Okay, so any problem before we end our lesson? Any problem? Please ask. Any? No, No, okay. If you have any question, you can ask, no problem. So I'll post the questions to the group, and you please do question 2 and 3 for today. Do the part that you can do. Okay. Tomorrow we will discuss using that questions. So I will see you in the next lesson. Thank you very much. Show the table again. No more. Okay. You have to read the video. Watch the video again. Okay. That's why you will do your revision after the lesson. Okay, now I'll see you tomorrow. Thank you very much for joining. Hope you enjoy the lesson. So after this, you don't log out.